This is an excellent problem because it has very practical applications. The one that I refer to the most is when you go into an elevator and you see that it says, oh, the elevator can only hold 18 people or 25 people or whatever it is, and you think, well, how do they know? How do they know how many people can fit in this elevator station? This is going to show us how that's calculated. So I'm going to read the problem. On October 5th, 2050, a tour boat named Ethan Allen capsized, sank on Lake George in New York with 47 passengers aboard. The maximum weight capacity of the boat was estimated to be 7,500 pounds. Data from the Centers for Disease Control indicate that weight of American adults in 2005 had a mean of 167 pounds and a standard deviation of 35 pounds. Use this information to estimate the probability that the total weight in a random sample of 47 American adults, that is, the 47 passengers aboard the boat, what's the probability that that would exceed? Excuse me. What's the probability that those 47 American adults would weigh more than 7,500 pounds? So what kind of information do we have that we should probably write down? Well, we should write down that the max weight 7,500 pounds. We should write down that we had 47 passengers. We should write down that the CDC says the weights of Americans follow a normal model, an N 167,35. That's probably important. So I think I'll just start off by drawing myself a picture. I have a normal model here, and here's 0 standard deviations, 1, 2, 3, -1, -2, -3. And so if I'm looking at my normal model, my inclination is to say I have 167 pound mean, and if I add 35, that is going to be 202. If I add another 35, that's 237. And I add another 35, that is what? 272. So I tried those on my calculator, and I filled in the negative ones, and those are all correct. So I'm looking at this, and I'm thinking, well, the maximum weight is 7,500 pounds. But that doesn't look like it's going to fit anywhere in my diagram. I mean, 7,500 pounds is, it's way over here. And clearly that's just not going to make any sense at all. Well, so thinking back at what the question is saying, it's saying that the CDC says the weights of American adults had a mean of 167 and a standard deviation of 35 pounds. Wait a minute. That's of each individual American adult. I have a boat here that has 47 pounds on it. I'm sorry, 47 American adults. So I have to make some changes. One approach would be to say, well, if the average American adult weighs 167 pounds, and I have 47 of those, then really my center should be 167 times 47. So my center would be 7849. But I have a problem with doing it that way, because even though that might give me the right mean, it might give me the right center for 47 people, it won't help me calculate the standard deviation. I can't just multiply 35 times 47 and think that that's going to be the standard deviation. That's not going to work. And one of the reasons I know that it's not going to work is because I know that the standard deviation for a distribution of sample means is calculated by taking the standard deviation and dividing it by the square root of n. Well, I know the standard deviation for each individual adult is 37, and I also know that my n, I'm sorry, 35, and we're making mistakes. And I know that my n, well, that's how many people I have on the boat. My n is equal to 47. So I can take 35 and divide it by the square root of 47. And I can find out 35 divided by the square root of 47. My standard deviation is going to be equal to, let's call it 5.11. Well, okay, I got my standard deviation, but how am I going to translate this 7,500 over here, which is the total capacity for the boat, into something that fits into my diagram? Well, if 7,500 is the total capacity of the boat, and I know that I have 47 people on the boat, then I can just take 7,500 and divide it by 47 and find out that my average weight can only be 159, now let's call it 59.6. That is what my average weight of those 47 people can be. 159.6, just to double check it, 159.6 times 47. That'll be just a tiny bit more than the 7,500 that I am allowed on the boat. So it's 159.6 that I'm really going to be working with. Now again, the tendency is going to be to take a look at this nice chart that I have right here and say, okay, well, here is 159.6, and what I need to do is find this area here using my normal CDF, and that will tell me the probability. But that would be a mistake, because this normal curve is based on the normal model of the population. Where's my n? My n 167.35. That is a sample size of 1. It's saying each individual in the population of American adults, if I took them all, they would average out to be 167 with a standard deviation of 35, picking them out one at a time. But I am looking for a sample size of 47, and I already calculated that the standard deviation for 47 adults, a larger sample size, is going to be 5.11. So I need to recalculate my diagram. What I'm going to be working with is an n 167. The mean stays the same regardless of the sample size, and a standard deviation of 5.11. This is what the model looks like for a 47 passengers boat, a sample size of n equals 47. So whereas if I had done it up here, you can see that my 159.6 fell between 0 and -1 standard deviation. When I do it accurately, what was it again? 159.6? Well, that's coming over here between -1 and -2 standard deviations. This is 159.6. And so the probability that the average weight would be above, the mean weight would be above with 159.6 is this entire area right here. So I need to calculate what that is. Now I'm going to go and use my normal CDF. So I'm going to go second distribution, normal CDF. Do not put in 159.6. That is incorrect, because remember the parameters of normal CDF are a z-score on the left and a z-score on the right. So I need to calculate the z-score for 159.6. All right, so that z is equal to y minus y bar over s. So in this case, it's equal to 159.6 minus 167, my mean, divided by my standard deviation of 5.11. So I get 159.6 minus 167 divided by 5.11. And I get a z-score of negative 1, let's call it 0.45. And I'm looking at my diagram. Well, that looks pretty reasonable. It's between -1 and -2, negative 1.45. Now I can go to my second distribution, normal CDF, and I'm just going to kind of highlight that and plug it right in. That's my left z-score. And my right z-score is way over here at the end. So we use positive 99 for that. So my right z-score is going to be 99. And I'm going to close the parentheses. I'm going to hit enter. And I'm going to find out, wow, there was a 92.6%. Let's write that in big green letters. 92.6% chance that that bolt was going to be too heavy. So that is what we call a lawsuit. And that's how you solve this kind of problem. That's how they solve these kind of problems when they're dealing with elevators. That's when they're solving these kind of problems when they're dealing with anything, dealing with how do you determine what the maximum weight is.